What's happening, dogs? Mr. Allen here with an introduction to Pascal's triangle and some binomial expansion. Now, these two go hand in hand with each other and make your life so much easier once you get into higher powers on these binomials. So check this out. If I wanted to do a plus b raised to the fourth power by hand, I'd have to multiply out a plus b times a plus b times a plus b times a plus b. This is the old-fashioned way, man, right? I'd have to multiply these two together. So a plus b times a plus b is going to be what? A squared plus ab plus ba plus b squared. And then combine my like terms because ab and ba are the same thing. That'd be what? 2ab plus b squared. But then this is all still getting multiplied by a plus b times a plus b. Oh my goodness. This is going to take forever. Perhaps there's a better way. Well, with Pascal's triangle, okay, this will give you your coefficients of each one of your terms based on what power you're raising it to. All right? So for the top one there, that's raising to the 0 power, which is just 1, right? Anything to the 0 power is 1. If I were to raise it to the first power, I'd get 1 and 1, right? So if I had a plus b raised to the first, that's just a plus b, right? That's it. I mean, it's just 1 for a and 1 for b. If I were to raise it to the second power, I'd have 1, 2, and 1. Oh my goodness, isn't this right here? Wasn't this the a plus b times a plus b or a plus b squared? It was. I got 1, 2, and 1. And if I were to raise to the third power, I'd have terms of 1, 3, 3, and 1 for my coefficients, okay? But then there's another pattern that follows thereafter when expanding, which we're going to get to in a second here, after I expand this triangle a little bit more. It's a lot to memorize, a lot of numbers. So perhaps if we know how to create each next row, then you don't have to memorize it. I'm going to help you out, okay? So it's always going to be 1s on the outside. To get my next one, if you notice 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. I've got the next row. Then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 5 and 1. Let's do one more just for fun, just because it's so fun. All right? 1, 6, 15, 20, 15, 6, and 1. Dang. That's dope. All right. Now notice, too, that each one of these rows, this is when n is 3, my exponent's 3. We're talking about this guy right here being n, okay? So the number in here actually matches up to the exponent of that binomial. How convenient, okay? So let's deal with this a plus b raised to the fourth power now. Shall we? We shall. I find it helpful to have 3 different colors in this scenario here, which is what I'm going to do, okay? If it's raised to the fourth power, these are my coefficients. Okay, so we got 1, 4, 6, 4, and 1. Now, the next term, I'm going to do this guy in blue, so this will be my a. All right? So it's going to be a, and my first term is going to match the exponent of that binomial. Note that for this guy being squared, my a squared was first. So this will be a to the fourth. And then notice that my second term here was a to the first, and then it was gone. The exponent was decreasing by 1 each time. So now I have a to the third, a to the second, a to the first, and a to the 0 power. And then for my b, this guy right here, I will have b to the, I'll start with 0, then b to the first, b to the second, third, and b to the fourth. Now for this one, since it was addition in there, everything's going to be positive for my final answer, right? If it was negative, you'd see these signs switch. And there's some other examples, videos that I'll put together for you that will have those types of things going on. This is just an introduction here. Your a and your b could be anything. It could be 2x plus 3y. And then you'd have the 2x raised to the fourth. And the 3y all raised to the 0. 2x raised to the third. 3y raised to the first, okay? So different examples with time. So here, it's 1 times a to the fourth times b to the 0. B to the 0 is just 1, so we're just going to have a to the fourth power. Plus, here, I've got 4 a cubed b, so 4a cubed b. Next one, I've got 6a squared b squared. Here we have 4a b cubed. And then we have 1, a to the 0 is 1, so it's just b raised to the 4th. There we go. That's pretty cool, man. That's my final answer. That's expanded. If I were to have kept going, right, like I was doing up here, and I multiplied in the a plus b, or I multiplied these together and then multiplied all both trinomials together, I'd eventually get there. Just be a real pain. And imagine doing it to like the 6th power. Oh my goodness. I don't even want to think about that. It's going to give me nightmares, all right? One last cool bit about Pascal's triangles. Kind of neat. So if you were to have, say, think of like a and b as like your heads and your tails of a two-sided coin, right? This would be the number of ways you could possibly have a certain event happen. So 4 heads in a row. There's only one way of that happening. If I had 3 heads and 1 tails, there's 4 ways of making that happening. All right, so I could have 3 heads, so we could have heads, 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 tails, or I could have heads, heads, tails, heads, so on and so forth. There's 4 ways to make that happen, 6 ways to make that happen, 4 and 1. That might have been too much there, but I found it fascinating. It's kind of cool that it works with like probability as well, and all these different math things are connected. Anywho, guys, main thing I think that a lot of people will use it for is binomial expansion. So there we go. Know how to make the triangle, know how to use it. It's awesome. I like 3 colors, and I like math. See you later.